let's talk about the law of sines. The law of sines is another tool that allows us to find relationships in any triangle, not just right triangles. I find the law of sines to be kind of mind-blowing if you stop and think about it. What it's saying here is that any side of a triangle divided by the sine of the angle opposite it is equal to any other side in the triangle divided by the sine of the angle opposite it. So recall that often when we're dealing with trig, we call the sides opposite the angles by the lowercase letter. Angle A, uppercase, is across from side A, lowercase. Angle B is across from side B. Angle C is across from side C, right? So that's what this is saying. Any side of any triangle divided by the sine of the angle opposite is proportional to, or is equal to, any other side divided by the sine of its opposite angle. Now, you often see the law of sines written like this. When I learned it in high school, many years ago, back in the dark ages, we just saw it like this, right? It was just a proportion, which is how we're always going to use it, right? A stands for any side of any triangle divided by the sine of the opposite angle, and so on. Sometimes you'll see it like this, right? If you see the law of sines like that, don't think, oh my gosh, it's totally different. Spend a few moments there, and I think you'll see, especially if you multiply, product of the means equals the product of the extremes, you'll see, oh, these are equivalent. You're going to end up at the same place. All right, so law of sines uses, I think you can see, two sides, or gives us a relationship between two sides of a triangle and their two opposite angles. So we recently talked about the law of cosines. We'd be using the law of sines in different scenarios. Let's try one. So let's say I have angle C is 31 degrees. Let's say angle B is 88 degrees. And let's say that the side opposite B is 12 centimeters. All right? So let's find side C. That's our mission. Should we choose to accept it? And let's. Okay, so I was given angle C. I want to find side C. I was given angle B. And I was given side B. Here I go. Let's set up a proportion. Again, don't be wedded to A's and B's. This just stands for any side. So let's throw in 12 divided by the sine of the angle opposite 12, which is 88 degrees. Okay? Equals another side, well, that's my unknown, divided by the sine of the angle opposite it. And voila. I have a proportion. Product of the means equals the product of the extremes, also known as cross multiplying. Although I hate to say that because then people cross multiply when they're multiplying fractions, which makes any math teacher want to run screaming from the room. All right, here we go. Boom and boom. Again, we're in degree land. Make sure your calculator is in degree land. Very simply, put this in your calculator. 12 times the sine of 31 divided by the sine of 88. And we get, for C, 6.184. So that's around 6 centimeters would be the side. Okay? Fun. That was nifty. Hey, if I wanted to, could I find side A? Well, sure. I think we have enough information to find angle A, and I don't really need trig for that. We know that the 3 angles of a triangle add to 180. So let's go ahead and do that. So 88 degrees plus 31 degrees plus angle A has to equal 180 degrees. 180 minus, whoops, I don't have my glasses on, that was divided by 180. Minus 88, minus 31. So angle A is 61 degrees. 61 degrees. All right, and then you could set up another ratio to find side A. Sometimes if we find all 3 angles and all 3 sides of a triangle, we say we have solved the triangle. In other words, you've just found all the ingredients, which is fun. All right, I'll leave you to find